Hello everyone. As you remember in the last lecture, we talked about text classification. Within this classification task, we discussed that there are two ways. One is the traditional way of doing the text classification, and the other way is the deep learning based text classification, where we use more advanced models like recurrent neural networks to achieve this objective. Let's review the key concepts once again, and then we will see how we can implement both the approaches, the traditional one and the deep learning based one, using Python. So let's start with a quick review of those concepts once again. We discussed text classification problem with the help of one example, which was spam email filtering, where given an email, we want to identify whether the given email is an spam email or not. So here once again we have the XY pair, as you remember, but X is not well arranged in the form of the tabular format with x1, x2, xn as the independent variables. But on the other hand, we have this text as the input. So when we deal in the traditional way of machine learning, what we do is we take this unstructured form of text and we somehow convert that into the corresponding structured form, which is more arranged, has lots of independent variables, and then the corresponding class. For that, we apply a lot of pre-processing steps like converting the text into one case, either lowercase or uppercase, removing the email addresses, removing the numbers, carrying out the stemming, means keeping only the root word, and tokenization, and so on. So the list of pre-processing is quite long, but once we do that with the available email, let's say this is the email, we saw this example in the last lecture also. We take this text of the email and after applying the pre-processing step, we convert that into this format, where this represents the set of independent variables x. And if you remember from the last lecture that this 2000 is actually the set of unique words available in all the texts or all the emails combined, and it is called the vocabulary that we have created out of these emails. And of course, we then have the corresponding class also, one representing that it is an spam email and 0 represents that it is not an spam email. Once we have done this with the help of pre-processing steps, now we can apply any standard machine learning algorithm on this, like logistic regression and even traditional neural networks. However, in the case of deep learning approach, we rely on RNN, recurrent neural networks, for text classification. If you remember, recurrent neural networks are very useful when the data is sequential, where the next input depends on the previous input. And within this context also, a few pre-processing steps are required. We take the words or even characters and we from the text and we divide them into tokens. This process of taking a text, dividing them into words or characters called tokenization. Then we convert the words into numbers so that it is more meaningful to supply this numeric data now to the recurrent neural networks. And since all the text may not be of the same length, then we also apply the padding process, where zeros are inserted into the sequence of integers corresponding to a text, so that all the text or all the emails in our case have the same length. Once we have done this pre-processing step, then the next step is to create a deep learning architecture using recurrent neural networks. This model and this architecture usually contains three common layers: the input layer, where we also do the embedding. Embedding is a more dense representation corresponding to each integer which represents one token of the text. Then we add some recurrent layers like LSTM, by LSTM, and there are other types of recurrent layers also. They are more advanced in nature, and they have removed actually some of the shortcomings of the traditional recurrent layers. Finally, we have the output layer where the final predictions are made. So this is the process of carrying out the text classification task by using the traditional approach as well as the deep learning based approach. Now let's try to implement all these concepts with the help of Python libraries. Let's see how this works. So welcome to the Google Colab, and let's see how we can implement text classification using the traditional approach. First, the bag of words approach. For that, we will first upload the dataset. For that, I have already mounted my drive where I have this dataset of emails, where some emails belong to the spam category and some emails are not spam emails. Afterwards, we will use some of the key libraries here. So we will use the pandas library to read the data, and using the sklearn library, we will fetch different necessary components which are required in this task. So we will use the train and test split module. We will also use the count vectorizer module, which is used to create the vocabulary of the words. We will use the artificial neural network. For that, we will use the MLP classifier, the multi-layer perceptron classifier. And finally, once the classifier is trained, we will use measures like accuracy, confusion matrix, other classification report to show how the model is performing on test set. So let's run these libraries also. Now the next step is to read data from the Google Drive. Now this data variable contains all the emails. Let's see a few of them. So as you can see here, we have two columns here. The first one is the text, the other one is the class, that is spam. So you can see that for some email, the value of spam column is 1, representing it is an spam email, and for rest or some other emails, you will find in the data set that the spam value is 0. Now as we do always, we will separate the text and the y, that is spam column here. We will store text in the variable x, and y will contain all the category values 1s and 0s corresponding to all the emails. We can also check how many emails are there in this data set. So a total of 5,726 emails are there. Some of them are spam, some of them are not spam. We can also check how many of them are spam. So out of 5,726 emails, 4,358 are non-spam emails and 1,368 emails are spam emails. Now let's divide the available data set into training and testing data sets. We are considering 20% of the overall data set as test, and rest of the 80% is the training data set. So once we execute this, we have divided data into training and test set. Let's check their size also. So training data set overall contains 4,580 emails, and test set contains 1,146 emails. Now to apply or rather implement the bag of words model, the first step is to create the vocabulary. For that, we are using this module count vectorizer. It takes the training data set and generates the set of all the unique words which are there in the whole training data set. We are calling them X-train vectors now. And using the same transformation, we have converted the text of test data set also and we have converted that also into vectors and numbers. If you want to check the size of the vocabulary created by this count vectorizer module, let's check that also. So after doing the vectorization on the training data set, the overall vocabulary size is this much. It means that our vocabulary contains a total of 33,566 unique words in this vocabulary. Let's check out a few items of our library, of our vocabulary. So these are the common occurring words, unique words, in the vocabulary. So the word RE is there in the vocabulary at the index number 25,134. 01 exists at index number 74, and so on. So this vocabulary is actually contains lots of words, and each word has a certain index. If we now check the size of the training vectors, now you will find it is not only a single column vector now. The number of emails will remain same, but each email has been stretched into this big vector corresponding to vocabulary matching the index, and that's why the number of columns are also exactly the same as that of the number of words in the vocabulary, which is 33,566. So for each email, it is compared with the vocabulary and the words available in the vocabulary. If the first word of the email exists somewhere in the vocabulary, then the corresponding index will be set as 1, otherwise it will be 0. The second word of the email is then checked, and so on. This is why we have so many columns, which are equal to the number of words in the vocabulary. Once we have done, so far we have pre-processed the data and made it in a form that it can be now applied to any standard machine learning algorithm. So we can create now an MLP classifier with certain architecture. In this specific case, we are using 2 hidden layers, each having 100 neurons, and other values are also mentioned here. We can run this, and this new model is created where we can pass on the text in the form of vectors once again, and the corresponding label, which is contained in yTrain variable. Now I am not going to fit this data right now here because it will take a lot of time. I have already trained it. So let's directly go on to the results. Once we run this and the model is fitted on the training data set, then the next obvious step is to predict the accuracy. For that, we will pass on the test vectors, store the predictions, and compare the predictions with the actual test values, and you can check out that the accuracy obtained here is quite good, 98%, and even above that 98.7% around. So it is a good accuracy. One of the reasons for getting this accuracy lies in 2 facts. The first fact is that the data is easy to actually distinguish or classify into two classes. So it is not a very difficult data set. At the same time, the architecture we have considered for MLPs is quite heavy. We have the input layer, then we have 2 hidden layers, and each hidden layer contains 100 neurons. So it is a heavy architecture overall. Nonetheless, we can calculate other performance measures also. I have already done it, and you can see this confusion matrix also, and you can also check what is the precision value, what is the recall value, and F1 score value. So what I want you to remember right now is that the accuracy on the test set was 98.7%, because we will then compare it with the deep learning based architecture. So this is how we can implement a text classification task using the traditional way of bag of words approach, and then we can apply any standard machine learning algorithms on that. Now let's move on to the deep learning way of doing the same. So to carry out the text classification task using deep learning approach, some of the early steps are similar. So as you can see here, I have already mounted my drive. Let's read the data. The same data that we have used earlier of emails. Let's check a few emails once again. So we have this email and the corresponding class is also mentioned. Now to implement the deep learning approach, here also we need to do a few pre-processing steps. If you remember, in the case of deep learning, the pre-processing we do is we apply the tokenization. If you remember, we divide the sentence into words. Then we also add zeros to that, so that each email is of equal size. We call this process padding. We also remove the unnecessary words which does not add much into the meaning of the text. We call them stop words. So for example, will, and, if, are, they are the examples of stop words. So for that we have used these libraries. So tokenizer is available in Keras. Pad sequences also available in Keras. Train and test split, we are taking it from the sklearn library. And there is a very powerful library for specifically for natural language processing tasks such as text classification. It is called NLTK, the Natural Language Toolkit. So TK stands for toolkit. So it contains modules for tokenization. It contains lots of inbuilt corpus. The stop words of different languages are available in this library. So it's a very heavy library, and you will find its usage is really common in natural language processing tasks. Lastly, we have also used a library for regular expression, RE. So regular expressions are very useful when you want to match a certain pattern in your text or in your string. So you can search certain pattern, you can match with certain pattern, you can split on the basis of certain pattern of words and characters and special characters. And for those tasks, regular expressions are very useful. So let's install these libraries. Now using NLTK, we will download the stop words, and we are specifically mentioning the stop words related to English. And let's print this list of stop words. Also, you can see that the words like add and if and what and before, they do not add much to the meaning. That's why they are there in this list of stop words. So when we will process our text, we will check whether these stop words are there in our text, and if so, we will remove these words from the original text. For that, for the pre-processing, we have defined a function. We have named it as clean text. It will do a few things. First of all, it will convert the whole text into the lowercase characters. Secondly, we will remove all the punctuation marks there, and we are using that with the help of regular expression. So this expression basically suggests that we want to keep only the words, characters, and white spaces like space and tab, but anything other than that, for example, comma and special characters, they are going to be removed. Lastly, we will check for each word whether there exists a stop word in that, and if so, we will remove that word also. So this function will do three things. It will convert the whole text into lowercase, it will remove the punctuation marks, also it will remove the stop words. So then we will apply this method clean text on our text column, which contains all the emails, and we will create a new column now with the name clean text. Now let's see how our data frame has changed now. So we already had text, we already had spam. Now we have one more column, clean text. And you can see that if you check the second email, the has been removed, is has been removed, and so on. Now the next step, we will use the tokenizer module now, and we will apply that on the clean text column. And what it will do is it will take the words, match that with the available set of words, that is vocabulary, and will generate the sequences by comparing the words with the vocabulary. So if we do this and print the sequences of a certain email, you will see that the words that were there in the text are now converted into numeric numbers. Also, different emails might be of different size. So what we do is we do the padding, that is we insert zeros at the beginning or even at the end of the email, so that all the emails which have now been, by the way, converted into integers, all of them are of the same size. So after padding, you can check the same email and you will see that we have some zeros here which have been padded at the initially at the front of the email. But if you want to, you can also add the zeros at the end of the email also. And remember, the email now does not seem like word, it contains numbers. Then we will divide our data into training and testing data set. We will use the same distribution as we have used earlier, 20% for testing and the rest of the 80% for training process. So training size is 4,580 and test size is 1,146, and each of them contains these many columns now, because 4,869 is the size of the maximum maximum length email, right? So each email after padding has become of same size, which is 2,869. Now let's create the RNN model. For that, we will first take the sequential model. Once again, sequential model here means that we will have one layer. It will process the input will go into the next layer, and since we are maintaining that in a sequence, that's why we are considering a sequential model. We will consider different type of layers. So embedding layer is there. LSTM we will consider as the recurrent layers here. We will also use the dense layer, and dropout we will also apply, and we can use early stopping and some other callbacks also. So this is the model architecture. We are using first of all an embedding layer. In this specific case, embedding layer has three parameters. The first parameter is the input dimension, which is equal to the size of the vocabulary or size of the set of the unique words that are there in the training data set. That is our first dimension, the input dimension. The second dimension is how each word, what should be the dimension of each word after applying the embedding process. So this dimension is 100. So let's say if a word was there in the text, first by comparing with the vocabulary, it has been converted into an integer. And now this integer is being represented as a 100-dimensional array which contains the intrinsic meaning of this word. So we can vary this dimension also. The last is what would be the input length of the text, and it is the maximum sequence length, which is 2,800 something we have seen earlier. So this is how we have created an embedding layer. Next is the LSTM layer, which contains 128 nodes. After that, we are applying a dropout of 0.2. After that, one dense layer with 256 nodes, and activation function is ReLU. And finally, we have the last layer which contains only one neuron, and the activation function is sigmoid because it is a binary classification task. So one neuron is handled. So in this way, we can create this model architecture. We can also mention what kind of optimizer we want to use. So in this specific case, we are using the Adam optimizer. We are using the binary cross entropy as the loss function because it is a binary classification problem. And as matrices, we are using accuracy as a matrix. And if we run this, then our model has been compiled. We can also check the summary that what is the input dimension and output dimension of embedding layer, how many parameters it contains, and so on for the rest of the layers. Now we can finally fit the data, the training data, into our model. Here also we are considering a validation split of 0.5, batch size is 32, and number of epochs are 2. Running it might take some time, so I will not run it here. I have already ran it, so let's directly go on to the result. Once the training is done using this model, next we will evaluate our model by supplying the text which is available in the testing set and the corresponding label values, that is y test. By applying the evaluation module, you will see that the test accuracy turns out to be 99%, more than above 99%, 99.21 to be specific. So if you remember when we did the traditional way using the bag-of-words approach, the same data set, the same distribution of training and testing data set, but there the answer was 98 point something, I think 7%. But in this case, using the deep learning, the accuracy has been improved. And this margin is much larger when we have more complex text classification tasks. Apart from accuracy, we can also calculate other measures like precision, recall, and others. We can also plot the confusion matrix. And as you can see that even the precision, recall, and FM score values have been improved. So in this way, we can implement the text classification task using the deep learning approach. So this is all about text classification. Thank you.